Welcome to MRL. In this learning session, we'll be learning the solutions of different exercises of the chapter number system of NCERT 9th standard, the textbook, old textbook, 25-26 textbook, which is being used by different state boards. Now, let us begin with exercise 1.1, and the first question in that is 0 a rational number? Yes, 0 is a rational number because 0 can be expressed as a p by q form, that is 0 by 1, and therefore 0 is 100% a rational number. Now to find, the second question is to find 6 rational numbers between 3 and 4. As you all know, there are different methods of finding out the rational numbers between given numbers. Now here I have adopted the denominator method. Now what I will do is, now since 6 rational numbers are asked, I'll take 1 plus one number more than that, that is 7. So multiply 3 into 7 divided by 7, that means make the denominator as 7. So it will be 21 upon 7, and 4 into 7 is 28, 28 by 7. Once I get 21 by 7 and 28 by 7, then the 6 rational numbers between them are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7 are the required 6 rational numbers between 3 and 4. A very easy method, we can adopt this method. Okay. Now coming to the next question, to find 5 rational numbers between 3 by 5 and 4 by 5. Now 3 by 5 and 4 by 5 are both rational numbers, and the denominator is same here. Once the denominator is same, it is again very simple. Multiply by 5 plus 1, that is 6. Making the denominator as 30. So 3 into 6, 5 into 6, that is 18 by 30. 4 into 6 and 5 into 6, that is 24 by 30. So in between 18 by 30 and 24 by 30, we have the required 5 rational numbers, and they are 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. So very easy method, and try to remember that. Now coming to the next example, number 4. To state true or false with reason. You have to give the reason and also state them whether they are true or false statements. Every natural number is a whole number, 100% true, because the natural number set is a subset of whole number. All the numbers of natural number set are present in whole numbers, and therefore natural numbers is every natural number is a whole number, and that is 100% true. Now second statement is every integer is a whole number, 100% a false number, because integer set is not a subset of whole number set. Whole number set is a subset of integers. All the whole numbers are present in integers, and therefore every whole number is an integer is the correct statement. Every rational number is a whole number. Every rational number is a whole number. Again, it's a false, because rational numbers are not subsets of whole number set, whereas the whole number set is a subset of integers. Integers is a subset of rational numbers. Therefore, whole numbers is a subset of rational number set, and therefore every whole number is a rational number, and the statement which is given is false. The correct statement is every whole number is a rational number. Now remember that. Now coming to the next exercise, exercise number 1.2. Again, the first question is to state true or false with reason. Every irrational number is a real number. Every irrational number is a real number, 100% a correct answer. That is, it is a true statement, because irrational number set is a subset of real number set, because that is Q dash is subset of R. Real numbers is a set of both rational and irrational numbers, and therefore every irrational number is a real number. Now the second statement is every point on the number line is of the form root m, where m is a natural number. This is a false statement, because m is a natural number. Square root of m is always positive. Square root of m is always positive. So no negative number can be root m, and but on a number line we have the negative numbers also located, and therefore root m does not represent every point on the number line. Every real number is an irrational number. Every real number is an irrational number is again a false statement again. Here the irrational numbers are a subset of real number set, and therefore the statement is wrong. If you take for example 2 is a real number. 2 is a real number but not an irrational number, and therefore every real number is not an irrational number, but irrational number is, every irrational number is a real number, and that is the correct statement. Now, are the square roots of all positive integers irrational, or are the square roots of all positive integers irrational? No. Why? Because if I take an example here, 4 is an, if I take the 4 as a positive integer, if I take the square root of that, it becomes 2, and 2 is, as you see, is not an irrational number, it is a rational number, and therefore every, that is all the square roots of all positive integers cannot be irrational. Remember that. Now representing root 5 on a number line. Now to represent root 5 on a number line, Now first of all, root 5 lies between 2 and 3. Root 5 lies between 2 and 3. Now first of all, we have to find out the measure of root 5, because we cannot measure root 5 on a scale. So we have to go for by geometrical method, and the geometrically we can find the value of root 5. For that we have to construct a triangle with the base AB as 2 units and the perpendicular of 1 unit. So when I make a triangle ABC here, applying the Pythagoras theorem, AC square is equal to AB square plus BC square, and therefore it is 2 square plus 1 square, and that is 4 plus 1, that is 5. Therefore AC becomes root 5. So now I can measure AC and get the value of root 5, or the measure of root 5. So now for that, now to locate root 5 on a number line, we have to construct the triangle of the same type of triangle on a number line, and then find out the position or the location of root 5 on the number line. And for that, I have drawn a number line here. I have drawn a number line, that is integers number line, and from 0 I have located 2, that is 2 units. From 0 it is that is AB is 2 units, and BC is, I have drawn a perpendicular, and BC is 1 unit. AC is joined. Now by Pythagoras theorem, root 5 is measure of root 5 is known to us, that is AC is root 5. Now taking A as the center, with A as center and AC as the radius, cut an arc to cut the number line at point P, and the point P represents root 5 on the number line. It's a very simple construction, and that is how we locate root 5 on the number line. Now coming to the next exercise, that is exercise 1.3. Now to find the type of decimal expansions given the P by Q forms. Now 36 by 100 is 0.36, 100% a terminating decimal expansion. 1 by 11 is 0.09 bar. I have found out here 1 by 11, it is 0.09 bar. It is a non-terminating recurring decimal expansion. 4 integer 1 by 8 is equal to 33 by 8, that is equal to 4.125, and therefore it is a terminating decimal expansion. 3 by 13 is equal to 0.230769. It's a non-terminating recurring decimal expansion with a period of 6 digits. Definitely it is a period of 6 digits, and that's what I have shown the calculations here on the right side. 2 by 11 is equal to 0.18 bar, 0.18 bar. So 2 by 11 is 0.18 bar, a non-terminating recurring decimal expansion. 329 by 400 is equal to 82.25 divided by 100, that is equal to 0.8225, which is a terminating decimal expansion. So you can find out the values by division and then decide what type of decimal expansion it is. Now coming to the next example number 2. 1 by 7, we are given 1 by 7 is equal to 0.142857. That means it is a non-terminating recurring decimal expansion with a period of 6, that is 7 minus 1 is 6. And we have to find out the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 without actually carrying out the long division. Now please understand here, 7 is a prime number, but it is a special prime number, that is 7 is a rep10 prime number. That means 1 by 7 gives a decimal expansion which is non-terminating recurring with a period of 7 minus 1, that is 6 digits. Not only that, when 1 by 7 when multiplied by 2, 3, 4, 5 and 6 gives a cyclic pattern of the 6 digits. And now for finding out the values of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7, we have to just multiply 1 by 7 value with 2, 3, 4, 5 and 6 to get these values of 2, 3, 4, 5, 6 divided by 7. Now for that, now let us begin. 1 by 7 is equal to 0.142857. Now to find 2 by 7, just multiply 0.14257 by 2, we get 0.285714. Then for getting 3 by 7, multiply that by 3, we get 0.428571. To get 4 by 7, multiply 0.142857 by 4. For getting 5 by 7, multiply 5 by 0.142857, and for getting 6 by 7, multiply the same value by 6, and we get all the 7 decimal expansions, all the 6 decimal expansions, 1, 2, 3, 4, 5, 6 decimal expansions, and all, if you observe them, they have a cyclic pattern. In the first case it starts with 1 with the same digits, with the second case it starts with 2 with the same digits, in the third case it starts with 4 with the same digits, and the fourth case it starts with 5 with the same digits, and so on, and they have a cyclic pattern. And all the number of digits are 7 minus 1, that is 6 digits, which therefore the period of 1 by 7 is 6 digits, and similarly 2 by 7 also 6 digits, and that is how we find out the values of the given the expansions of the given P by Q forms. Now coming to the next example, to find p by q form of 0.6 bar. Now 0.6 bar is a pure decimal expansion, and to find out the p by q form of this, x is equal to, let x be equal to 0.6 bar, 10x is equal to 6.6 bar, 10x minus x is equal to, that means subtract x is equal to 0.6 bar from 10x, so 10x minus x is equal to 10x minus x is equal to 6.6 bar minus 0.6 bar, and 10x minus x is 9x, and 6 bar cancels here, the what remains is 6, x is equal to 6 by 9, or x is equal to 2 by 3, and therefore 0.6 bar is 2 by 3, remember that. Now to find out 0.47 bar, now it is impure decimal expansion, it is an impure decimal expansion, and please remember that, please refer or go through the basics of this in the videos which are already there present available in the on the channel, by which we can understand why it is pure and impure. Now first of all, it is impure here, so you have to make it pure first. So let us assume x be equal to 0.47 bar, 10x is equal to 4.7 bar, that means I have removed the 4 towards the integer part, so it becomes 4.7 bar. Now it has become pure, because after the decimal point only the repeating part is there. So now bring the 7 to the left, that means I have to multiply again by 10, so 10 into 10 becomes 100x, and this will 7 will move to the left, so 47.7 bar. Now subtract 10x from 100x and 4.7 bar from 47.7 bar, we get 47 minus 4, that is 43. So we get 100x minus 10x is 90x, and here it is 43, therefore x is equal to 43 by 90, or 0.47 bar is equal to 43 by 90 is the p by q form of the given decimal expansion. Now to find 0.001 bar, now it is again pure, and let x be equal to 0.001 bar, and since there are 3 digits, multiply by 1000x is equal to 1.001 bar, and subtract x from 1000x minus x is equal to 1.001 bar minus 0.001 bar, 0.001 bar gets cancelled, and here we get 999x equal to 1, and x is equal to 1 by 999, and therefore 0.001 bar is equal to 1 by 999. So please understand and learn. Now coming to the next example, to express 0.9999 in p by q form. Now let x be equal to 0.9 bar, because repeating, so it is pure. Now 10x will be 9.9 bar. Subtracting x from 10x, 10x minus x is equal to 9.9 bar minus 0.9 bar, 9 bar 9 bar cancels, x is equal to 9 by 9, x is equal to 1, and therefore 0.9 bar is equal to 1. Now very interestingly, the value of 0.999 is 1. 0.9 bar is non-terminating recurring decimal expansion. The space or gap between 0.999 and 1 is very negligible, and therefore approximation of 0.999 unending will be 1 only, and therefore the value of 0.9 bar is always 1. Remember that. Now to find the repeating period of 1 by 17. We have already learnt about 1 by 7. We have learned that 7 is a reptent prime number and gives us a decimal expansion which is non-terminating recurring with a repeating block of 6 digits, and so also 17 is also a reptent prime number, therefore it gives us a non-terminating recurring decimal expansion of a repeating block of 16 digits. So that is what you have to remember. So therefore the decimal expansion of 1 by 17 is a non-terminating recurring decimal expansion with a period in the repeating block of 16 digits. Remember that. Now coming to the type of decimal expansion p by q without dividing, we have to find out the type of decimal expansion of p by q without actually dividing it. Now how to do that? If p by q is a rational number with 1 as a common factor, that means p by q are co-primes here. So p by q will have terminating decimal expansion. P by q will have terminating decimal expansion. Remember that any rational number will have two types of decimal expansion. One is the terminating, the other one is non-terminating recurring decimal expansion. Now to find out what type of decimal expansion p by q will have, we have to check the q factors of q there. If the factors of q are multiples of 2 or multiples of 5 or multiples of product of 2 and 5, multiples of product of 2 and 5, or 10 or multiples of 10 or power of 10. So 2 to the power of m, 2 to the power of m into 5 to the power of n, or only 5 to the power of n, or 10 to the power of p, will find that p by q will have a terminating decimal expansion. Therefore remember, p by q will have a terminating decimal expansion if q is having the factors of powers of 2, powers of 5, or product of powers of 2 and 5, or only powers of 10. So under these conditions the p by q will have a terminating decimal expansion. Now in the second part is when it will have a non-terminating recurring decimal expansion. Non-terminating recurring decimal expansion. The p by q will have a non-terminating recurring decimal expansion if the factors of q do not meet any one of these conditions. That means they are not the factors of 2, not the factors of 5, not the factors of product of 2 and 5, and the factors of 10, but the factors are totally different. Now if you observe here, 28 by 685 has the factors 5 into 137. 137 is a prime number and definitely different from 2, 5 and 10, and therefore the 28 by 685 will have a non-terminating recurring decimal expansion. So therefore p by q, if you want to find the type of decimal expansion, then just check the factors of q and apply those conditions given here and then confirm what type of decimal expansion it will have. Now coming to the next example, to write three numbers whose decimal expansions are non-terminating and non-recurring. That means we have been asked to write three irrational numbers here. Now the first example is this, non-terminating, non-recurring, and second also non-terminating, non-recurring, and non-terminating. So a very simple way of writing, just a general way. Any example which is unending and not repeating, it becomes irrational number. Now to find three different irrational numbers between 5 by 7 and 9 by 11. So first convert 5 by 7 into a decimal expansion which is non-terminating recurring decimal expansion with 1, 2, that is 6 digits in the repeating block, and 9 by 11 is also a non-terminating recurring decimal expansion of 0.81 bar. Now we have to write three irrational numbers lying between these two, and the number should be lying between 0.7 and 0.8, and that's what I have listed here. So the three decimal expansions which are non-terminating and non-recurring representing irrational numbers are the three of them which are listed, which lie between 5 by 7 and 9 by 11. Try to understand that. Now coming to the next question, to classify the numbers as rational or irrational. Now root 23 is a prime number, root of 23 is an irrational number, root 23 has a non-terminating, non-recurring decimal expansion. Root of 225 is 15, root of 15 square, and that is 15, it is a rational number. 0.3796 is 3796 by 1100% p by q form, therefore it is a rational number. 7.478478 is having a repeating block of 478, and therefore it is a rational number. Now 1.101001, it is non-terminating, non-recurring decimal expansion, therefore it is an irrational number. Remember that. Now coming to the exercise number 1.4. Exercise number 1.4. Now first question is to classify as rational or irrational. Again, 2 minus root 5 100% is an irrational number because sum of a rational and irrational is 100% an irrational number. 3 plus root 23 minus root 23 is equal to 3 plus root 23, opening the bracket, I get 3, which is a rational number. Root 7 cancels here, therefore 2 by 7 is a rational number, or 2 root 7 by 7 root 7 is a rational number. 1 by root 2 is equal to 1 by root 2 into root 2 by root 2 is equal to root 2 by 2, and a quotient of a irrational and a rational is irrational, therefore 1 by root 2 is an irrational number. 2 pi, it is 100% irrational because pi is irrational and 2 is rational. A product of rational and irrational is always irrational, and therefore 2 pi is irrational number. Now simplifying the following, to simplify the following, that is 3 plus root 3 into 2 plus root 2, applying the distributive property, that means 3 into 2 plus root 2 plus root 3 into 2 plus root 2, simplifying we get 6 plus 3 root 2 plus 2 root 3 plus root 6, a very simple thing. Apply the distributive property and get the answer. The second one is 3 plus root 3, 3 minus root 3. Now applying a plus b, a minus b, that is a square minus b square. A is 3 here and b is root 3, so 3 square minus root 3 square is equal to 9 minus 3, and that is 6 is the answer. Root 5 plus root 2 square, applying a plus b whole to square, we get a square plus 2ab plus b square. A is root 5 and b is root 2, so it will be root 5 square plus 2 root 5 into root 2 plus root 2 square. Root 5 square becomes 5, root 5 into root 2 becomes root 10 to root 10, and root 2 square is 2, therefore 5 plus 2 is 7, 2 root 10 plus 7 is the answer. Now the fourth example is root 5 minus root 2, root 5 plus root 2, it is a minus b into a plus b, again a square minus b square. A is root 5, b is root 2, therefore root 5 square minus root 2 square is equal to 5 minus 2, and the answer is 3, and a very simple calculation. Pi is equal to c by d. Now the question is whether pi is irrational or rational is to be confirmed here. Now pi is equal to c upon d, that means pi, the value of pi, which is a constant, is the ratio of the circumference of a circle divided by its diameter. Now, although it appears to be a P by Q form, but actually the measurement of the circumference of the circle and the diameter of the circle is an approximation. It is possible that the measure of C or D can be an irrational number, and therefore pi is taken as an irrational number. Now, to represent root of 9.3 on the number line, it's a construction here. We have to find out root of 9.3, and for that what we will have to do is, first we cannot find root of 9.3 directly. You can go by long division method, but geometrically if you want to find out the value of root of 9.3, we can find it out and also locate it on a number line. Now, for that, take AB. I have written here. Draw AB is equal to 9.3 units. AB is equal to 9.3 units. Draw BC is equal to 1 unit. Locate the midpoint M of AC. With M as center and AM as radius, draw a semicircle. Now, after that, draw a perpendicular at point B. Draw a perpendicular at point B, BD, which is the perpendicular which cuts the semicircle at point D. Now, measure of BD is equal to root 9.3. So, we have got the measure of root of 9.3 is BD is the equal to the value of root 9.3 is the length BD. Now, with B, what you call B as the center, okay, with B as the center, then measure BD, take BD as the radius and cut an arc to cut the line, that is the number line at point P. Please understand here that the point B is 0 of the number line, and so on. We have drawn the number line there, and it cuts the number line at point P, and the point P represents root of 9.3. So that is how we not only find the value of root of 9.3 but also locate it on a number line. So the method is very simple. Okay, remember this, and if you have any doubts, you can just put it across to me. I'll again further clarify it. Now, coming to rationalizing the denominator. Now, square root 1 upon root 7, we want to rationalize it. Now, rationalizing factor is root 7. So, 1 by root 7 is into root 7 by root 7. Root 7 by root 7 square is equal to root 7 upon 7 is what is the answer. In the second case, it is a binomial third, or 1 upon root 7 minus root 6 is the binomial radicals. Then 1 upon root 7 minus root 6, the conjugate of that is root 7 plus root 6, root 7 plus root 6, that is the RF, rationalizing factor is the conjugate of this. And root 7 plus root 6 divided by root 7 square minus root 6 square, root 7 plus root 6, root 7 square is 7 minus 6, and that is 1. So, root 7 plus root 6 is the answer. Now, the third one is 1 by root 5 plus root 2, 1 by root 5 plus root 2 into root 5 minus root 2 divided by root 5 minus root 2, again conjugate of this. Always remember, when it is a binomial third or a binomial radical, you have to take the conjugate of that. If it is plus sign, you have to take a minus sign. Now, simplified, root 5 minus root 2 and divided by root 5 square minus root 2 square, that is root 5 minus root 2 divided by 5 minus 2, root 5 minus root 2 divided by 3 is the answer. Now, the fourth example is 1 by root 7 minus 2, 1 by root 7 minus 2, and it is 1 by root 7 minus 2 into root 7 plus 2, root 7 plus 2. Now, here the conjugate is root 7 plus 2 because root 7 minus 2 there, and simplifying we get root 7 plus 2 divided by root 7 square minus 2 square, that is 7 minus 4, and the answer is root 7 plus 2 divided by 3. Remember that. Now, coming to the next exercise, that is exercise number 1.5, a very simple exercise this is, based on exponential notation. Now, to find 64 raised to half, 64 can be written as 8 square raised to half, and applying the laws of exponents, that is a raised to m raised to n is amn, 8 square into half, 2 cancels 8 raised to 1, answer is 8. 32 can be written as 2 raised to 5 and multiply by 1 by 5, it will be 2 raised to 5 into 1 by 5, again applying the law of exponents here. 2 raised to 1 is 2, 125 raised to 1 by 3 is 5 cube raised to 1 by 3, 5 cube into 1 by 3, that is okay, answer is 5. Now, to find 9 raised to 3 by 2, 9 is 3 square into 3 by 2 become 3 raised to 2 into 3 by 2, 2 cancels, 3 cube is equal to 27. 32 raised to 2 by 5, we can write 32 as 2 raised to 5, and that is 2 raised to 5 into 2 by 5, applying a raised to m raised to n is equal to amn, and then 5 cancel, 2 square is equal to 4. 16 raised to 3 by 4 becomes 2 raised to 4, 16 is 2 raised to 4, raised to 3 by 4 is equal to 2 raised to 4 into 3 by 4, 2 cube, that is 8. And 125 raised to minus 1 by 3 is equal to 5 cube raised to minus 1 by 3, and 5 cube raised into minus 1 by 3, 3 cancel, 5 raised to minus 1, 1 upon 5 raised to 1, and the answer is 1 by 5. So, the next that is example number 3, we have to simplify. 2 raised to 2 by 3 into 2 raised to 1 by 5, base is same, we can add the powers by using the exponent law of exponent, that is a raised to m into a raised to n is a raised to m plus n, and then so while taking LCM 15, then 3 5 are 5 3s are, that is 10 plus 3 by 15, so 2 raised to 13 by 15. Coming to the next example, 1 by 3 cube raised to 7. So 1 by 3 cube can be written as 3 raised to minus 3, because 1 by a raised to n is a raised to minus n, again laws of exponents there. So 7 3 is 21, 3 raised to minus 21 is the answer. If you want, you can write in this manner also. Now third example, 11 raised to half divided by 11 raised to 1 by 4. The base is the same, the powers are different, so we can go for the law a raised to m by a raised to n is a raised to m minus n, and therefore it is 11 raised to half minus 1 by 4, that is taking LCM 4, 2 minus 1, and 11 raised to 1 by 4 is the answer. Now the next example is 7 raised to half into 8 raised to half. Applying the law, again law here, a raised to m into b raised to m is a into b raised to m, therefore 7 into 8 raised to half, that is 56 raised to half. So therefore in all these cases we have to use the laws of exponents and solve them. Very simple examples if you remember the laws of exponents. So these were the different exercises of the number system chapter. Please go through them, solve them, understand them, practice them, but my suggestion would be to go through all the basics of the number system. Different titles are there, different videos. Go through all the basics first, be thorough with the basics, then calculations becomes very easy. Okay, thank you.